Now we're going to look at similarity without any numbers. And it's going to be the same thing. We're just going to use letters. So a little harder or more confusing, but it's almost less work, but just want to go over it. So we're going to figure out what proportion is correct just looking at the shape with no numbers. So really quick, if we looked at triangle ABC is dilated to create triangle A prime, B prime, C prime, what is the scale factor? Well, we want to just make sure we line up or match up proportional or corresponding sides. So I can use 3 and 2. Now, since I'm getting smaller here, I'm going from ABC to A prime, B prime, C prime. To get smaller, I got to multiply by 2/3, not by 3 over 2. So 2/3 would work. Another way we could have done it is these sides match up. I want to get smaller, 4 over 6. Now, that's not an answer choice, but I could divide 4 by 2. I could divide 6 by 2. And if I divide both of these by 2, just to simplify them, 4 divided by 2 is 2. 6 divided by 2 is 3, 2/3. So it's still 2/3 if I use these two sides. I just got to simplify it. But it's not 3 over 2 because we're not getting bigger. If we were getting bigger, that's what we would have done. All right, so what's the scale factor now? Ooh, this looks confusing, but it's the same thing. I just put the small side divided by the big side on the last one. So it's just B prime, C prime, divided by BC. That's all we did, right? With the numbers, we just did 2 over 3. So B prime, C prime over BC. So B prime, C prime over BC would work. That's all. Now, if I wanted to go and use A prime, C prime over AC, A prime, C prime over AC. So again, it's the same thing. We just don't have numbers, so we're just using the sides. Notice a few things. We want to make sure we're choosing corresponding sides. So AC and BC, A prime, C prime, and BC, those are not corresponding sides. So I can't use that one. BC over B prime, C prime, this one, that would make the triangle bigger. So if we were going bigger, we would put the bigger side on top. And then these ones are not corresponding, so I can't use those. So this one might have been a little confusing, but the rest should be pretty simple. So we want to make sure we use corresponding sides, and if we're getting bigger, we put the bigger side on top. If we're getting smaller, we put the smaller side on top. All right, so that was the big idea. So quick example here, triangle QSR is similar to RST. So I see those are both 90 degrees. Just really quick, if you wanted to see this, I'm going to transform it. Let's see. Oh, there it is. Transform. I'm going to rotate this. I'm going to rotate around here. I'm going to go 90 degrees. Let's see. I'm going to go the other way, though. So I'm going to go -90. No, I'm going to go this way. 90. There we go. See how that triangle would rotate there? And those triangles would be similar. So just wanted to show you we would rotate it and then use a scale factor. So if I was going to rotate this triangle, right, I'm going to rotate this blue one. So this is R, S, and Q. So I just rotated that triangle to make it match up a little better. So I just rotated that triangle, R, S, and Q. So RS matches up with RT. So I'm looking for RS and RT. RS, RT. This one. So let's just double check the other side. QR matches up with SR. Yep, those two sides would match up. And then RS over RT. So we just want to draw and match up those corresponding sides. This one's hard because you got to rotate it, and drawing it separate really helps. So if I did QR, this side, over RT, and then SR over RS, that really wouldn't work. So we want to just make sure we choose those corresponding sides. Had to rotate this one. They won't always be that hard. So for example, this one, I want to make AB and A prime B prime on the same. So A prime B prime over AB,